Today we're going to be looking at how do we know if something's a function given a graph. I'm going to go ahead and tell you guys right now this little graphic we have here, which is a very nice little representation of what a function looks like with a roller coaster, is an actual graph. And whoever did that did a great job. Because, roller coasters, if you look at them from the side, kind of look like a function. So, how do we know if something's a function looking at its graph? Remember that when we looked at charts, a function is a relationship between a set of inputs and outputs, so that no input has more than one output. But how can we look at a graph and take this concept we learned with charts and apply it to a graph? I'm going to go ahead and give you guys some examples of graphs that are functions. Here we have a function. Okay, then we have a functions graph here. Then we have a function, some points. Okay, and then here we have a function as well. This is called an asymptote, by the way. They all look very different, but they're all functions. So I want you to think about why that is. Then I want to show you a set of graphs that aren't functions. Here we have some points, just like we had before, but why is that not a function? Here we have a curve. Okay, here we have a circle. And here we have something that's not a function. There's nothing on it. Okay, we've kind of already learned about why that's the case. Let's go ahead and look at why these are and are not functions. When each point on the graph has no other points above or below it, it's a function. Why is that? Because each input has no more than one output. Remember, the y value, or the function value, in this case f of x, is the output, x is the input. And if you take any point on the graph, there are no points above or below it. Same for this line. For every x value, there's only one y value. Same for these points. There are no points above or below the points, so every x has one y. For example, 3 has 0. 3 doesn't go to any other point. Same for this graph. Now, this one gets really close at x equals 0. Looks like the graph almost overlaps it, but because of this asymptote, it does not. Now, the reason why these are not functions, just pick, for example, x equals 2. Well, it has two y values. It crosses up here around 2, and it crosses down here around negative 2. Two y values means it's not a function. Same for this circle. Almost everywhere on the circle, for each x value, there's two y values. At 0, y equals 4, but also at x equals 0, y equals negative 4. Up here, it almost looks like it works, but at 1, it goes to, there's a y value at 1, and at x equals 1, there's a negative 4. So whenever you have 2 points, and they're above and below each other on a graph, it's not a function. Okay, well, at least one point on the graph is a point above or below it, not a function. Recall a function cannot have more than one f of x value for each x value. What does it mean graphically? There can't be two f of x values on the same vertical line. Another way we can explain this lesson is called the vertical line test. Example 1, does the following graph represent a function? Alright, so I'm going to give you guys a set of steps. It's called the vertical line test. We're going to see, is this graph a function? Not the green line, that's our testing line, but the actual graph right here, is this a function? First, we're going to place a straight edge all the way to the left of the graph. Okay, and that's what we've done. Okay, we got our straight edge over here. If you're using a piece of paper to do your homework or whatever, you can use a pencil or something for your straight edge. Next, we're going to line it parallel with the f of x axis or the y axis. So just make sure it's pointing straight up and down. It's parallel with that. And now we're going to scan the plane slowly from left to right. So we're going to go like this. This is called the vertical line test. And look, I'm going from left to right. Does the straight edge ever touch the graph more than once in two places? In this case, no, right? It never touches more than once. So that means it's a function because no x value on the graph has more than one y value. Okay? So as we scan across, we see it only touches the graph once, never twice, the vertical line. If it touched twice, that means an x value would have two y values. It always only touches once, so this is definitely a function. And that's our reason. We want to give an answer for every time we say it is or isn't a function. Does the following graph represent a function? Here's example 2. Okay, let's place this all the way to the left. Okay, this vertical line, we'll put it right there so you can see it. Okay, and place the straight edge all the way to the left, align it parallel with the y-axis, scan the plane slowly from left to right. Then we're going to see, does it touch the graph more than once? Whoops, let's see if we can get this to move. Okay, So as we scan across, touching once, touching once, touching once, touching once, even there it's touching once because of that hole right there. It's not actually touching at -5, -3. But right here, what happens? That green line touches twice, and I'll even show you exactly what I'm talking about. It's touching here, and it's touching there. That's a problem. Okay, for example, at x equals -3, we have a y value of 3 and a y value of -3. That's not good. It can't be a function if it touches twice. And in fact, it touches twice more than once, but it only has to do that once for it not to be a function. So since it does touch twice, since the vertical line touches twice, the answer is yes, so it's not a function. At x equals -4, for example, there's two y values at 3 and -3, and of course, we already showed it. Also true at -3, there's two y values. So, not a function. You can't just say it doesn't pass the vertical line test. You have to be specific about where does it have two y values. Does the following graph represent a function? Example 3. Okay, again, let's take our straight edge and move it to the left. And now we're just going to go ahead and go straight into the steps. Okay, so I just want to scan this from left to right, and you can tell me, is it touching more than once? Nope. Touching once, touching once, touching once. Just so you guys are clear about what I'm talking about, this is where the vertical line intersects the graph. Okay, it's only touching once. It's not touching the graph anywhere else. Touching once, touching once, touching once. Again, touching right there. Touching once, 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 once. Okay, so right here, right there. How many times is it touching? Well, actually, because that's a hole right there, it's actually only touching once. It's only touching down there. It's not touching up there because it's a hole. Okay, this line right here is a little thicker than, I mean, imagine if the line was thinner. Okay, a line actually technically doesn't have thickness. It only connects 2 points. But anyways, if you can imagine it being as thin as possible, you could see then it doesn't, only touches once, only touches down there. Okay, so let's keep going. Scanning, 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 once, 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 once. Right here again, the line's a little thick, but if you imagine it being thinner than that, as thin as possible, you can see that it will never actually touch the graph twice. Okay, it'll only touch the graph once, and as we scan, continue scanning, it only touches once, 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 once forever. Okay, so we've done those steps, and therefore, since it only touches once at any particular place and not twice, it is a function. For each x value, there's no more than one y or f of x value. I want to make a couple notes about that graph. The input x equals 1 only outputs the -0.5 because there was a hole at 1, 2. We just kind of talked about that right there. There's the hole. And at x equals 3, there's a vertical asymptote. There is no f of x value even though the graph gets close to it. Okay, so vertical asymptote right here means the graph will not touch. So there's no way it could touch twice, right? So there you go. Let's look at example 4. Is this a function? Okay, well, let's go ahead and take our green line, our vertical line, and scan. Touching once, touching once, touching once, touching once. Again, it's only intersecting the graph right there. Only place it's really going to matter maybe is right here, right? But notice, it doesn't touch up here and it doesn't touch down here. Those are holes. Holes meaning the graph doesn't actually have a point there. It stops there. It does touch there once, so that's allowed. Let's keep scanning. Touching once, 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 once. Always only touches once. So this is definitely a function. Never touches twice, okay? So therefore, every input only has one output, and so it is a function. Let's look at another example. This is a practical example. Let's read this together. Various people were measured and weighed. Following is the graph of the data. Is weight a function of height? All right, so down here we have height in inches. Here we have weight in pounds. Okay, so this first person right here is 55 inches and weighs 120 pounds. Next person looks like they're about 57 inches and weigh about 100 pounds. Here's a problem right here. Okay, somebody that's 68 inches weighs 120, and then somebody else that's 68 weighs 140. If we scan the vertical line, touching once, not touching at all, which is fine. We talked about that. It doesn't have to touch everywhere. It just can't touch twice, which in this case it touches twice. And so regardless of whatever else happens on the graph, it touches twice, so it's not a function. Weight is not a function of height. Clearly, I mean, practically, if you think about it, just because somebody's a certain height doesn't mean they're going to weigh the same. So that's it for a function looking at the graph. Just use the vertical line test and give a reason for your answer. If you have any questions, let me know.